Hello and welcome to Callum Conry. My name is Mr. Mackenzie. Unfortunately, the live sections didn't record the PowerPoint, it was just the audio version. So myself and Mr. Weatherhead are going to do the videos now so that you can sort of have a look back and then they'll be uploaded to the website. So I've taken the statistics side, so it's about a 20-minute video on past paper questions, the 2023 paper from it's from last year, and I've taken two of the questions with the topics that I've done, and Mr. Weatherhead will do the same. So if we proceed to the first section, I just grab my pen. So the two topics that I covered was data presentation interpretation and statistical hypothesis. Before going on to the questions, what I thought I'd do is do a quick synopsis of the two topics. That way, making sure that you understood exactly what was required. That way, then you can sort of proceed with the questions. For data analysis, it was our data presentation interpretation. You would have a scatter diagram, and in that scatter diagram, you were given the line of best fit in the form of y equals mx plus c, where y and x were the labels of whatever the axes were. And they would ask you to interpret, and that's the important word here, to interpret what the different values meant. So the interpretation of the c, which is the y-intercept, this occurs when y-intercept in the context of the question. And this is when x is equal to 0. So one I have seen is the number of kilocalories or calories when how much carbohydrates there are. So at this point, you would say that there are no carbohydrates, but there's still got calories, because calories could come from various different places. And then the other one is the gradient. And as I say, some questions will ask you just to state the gradient, and then other questions will ask you, what does that gradient mean? And again, every question with statistics has to be in the form of the context of the question. And what I would sort of highly recommend, as x increases by 1, is by 1 unit, I put it under here, on average, and that is an important word. If that word's not in, then you could lose the mark. Y increases slash decreases, depending if it's positive or negative correlation, by ... unit. Obviously with x and y, I don't want to see those. I want to see what the labeling is on the axis itself. Okay. Then also that we have the standard deviation, which you're going to have to calculate. Said about x bar, which is equal to the mean, and how you would calculate that is sigma x over n. And then the standard deviation formula is sigma x squared over n minus x bar all squared. And then when you have this value, the standard deviation is the central spread. I want you to talk about that spread. Okay, so if it's a large value, it would be spread out. And if it's a small value, it would be concentrated. Expect it to be, again, in the context of the question. The sigma x squared, that is either going to be calculated for you and put in. So they'll either have a table or they'll have a list of the actual values itself. And then you just pluck it in. That's all you're doing. Or if it's not, then you're going to have to square each of the different values. I have got one of the questions here, so that you'll see what I mean there. Next, hypothesis testing. If you have a look at the previous video, I have defined it, but I do want to define it here because it is important that you don't miss anything out. So hypothesis testing, the first thing you should do is define what x is in terms of the binomial with its parameters n and p, and to define what the random variable x actually is in the context of the question. If that has been done so beforehand, then you just need to define it in terms of the binomial with parameters. Once you've done that, you're going to be writing down the null hypothesis, H0, and that is P is equal to a value. That value you will take from the question. Your alternate hypothesis, which is H1, P. Now, if it is not equal to 0, then it is a two-tailed test, and you have to cut the percentage. So if it was a 5% at the two-tailed test, then you divide by 2, so you'd be looking for 2.5%. If it was 1%, then you'd be looking for 0.5%. If P was greater than, and it's not 0, sorry, it's the actual value. Let me rub that out. Value. If P is greater than the value or less than the value, then it's a one-tailed test. Okay, once you've done that, then you are going to look for the percentage or the decimal probability. So if X is less than or equal to the value, you will come up with, putting in the calculators. You can use the tables. I would highly recommend the white calculator. It just makes life that a little bit easier, but there's nothing wrong with using the tables. So X is less than or equal to the value. You get a decimal, which you convert to a percentage and compare. Once you have compared it, you write a conclusion in the context of the question. So you either reject, so you would say that reject H0 for H1 because there's significant evidence at the 5%, 1% level, and then write in the context of the question. Confer and compare conclusion, and compare with conclusion in context of question. The other thing that I want to sort of explain is this applied paper is a lot wordier than the pure. The pure, you've got one question, you simply answer it and then you move on. If you have a look at the applied question, you will see on the next slide. Here, there's a lot more writing and you have to make sure that you have understood the question. So just by reading that is going to be a couple of minutes anyway, and then understanding it at the same time. Whereas pure, you're used to reading it and getting to know a gist of the question straight away. So what I've sort of said to you before, or what I've said to my sort of pupils, is that if you look how many marks it is and it's getting you bogged down with 1 or 2 marks, you move on. Because the next question, it might be a case of you can answer the majority of it, but you're losing those marks because you're sort of focusing in on the 1 or 2 marker. Right, so here we go. Poppy and Claire are investigating Welsh language skills in Wales. Poppy randomly selects a sample of 20 different students from a school and asks them to state their Welsh language skills according to the categories in the 2011 census. She numbers the students in a school from 001 to 578. She uses a random number generator to select a sample. The first 6 numbers generated are shown below. Now this is like the old GCSE question from numeracy, where you would normally write what are the conditions for you to do a random number. It's already told you the conditions. It just now wants you, or the question just wants you, to write down which numbers you would choose. So the first one in the list, so if I write down A here, is 195, I'm going to put a tick because I'm choosing that. 752, I'm going to put a cross and I'm going to say why. So it's outside of range. Range goes up to 578. Then I'm going to go to 023, tick. 195, I'm going to put a cross, repeated. Bit more room in here. 432 and 271 are both ticks, and then I've answered the question. Claire selects a random sample of 20 students from a different school. Give 2 reasons why Claire's conclusion about Welsh language skills in Wales may be different from Poppy's conclusion. So again, part B. So 2 reasons could be that it's from a different area. one. And also one might be from a Welsh medium school and the other one from an English medium school. The Welsh medium just means it's from Welsh school. The data would be skewed from a Welsh medium compared to an English medium compared to anything that makes sort of sense. Full stop. Okay, now we've been given a load of data. So the data collected from the 2011 census for the two regions of Wales are shown below. So that is all of the data that they've collected. And looking at these data, and look at this data, Poppy concludes that people in region B, so it's listed there, have better Welsh language skills than the people in region A. Part C is, without carrying out any calculations, use the data from the table. So it's basically must use the data from the table to argue for Poppy's conclusion. So for part C1, we're saying Poppy's conclusion is region B have better Welsh skills. So if we have a look at region B, anything which is higher, there you go, that's 10.8 and that's 9.7. So because of the percentage of speaking Welsh in B is 10.8, which is greater than 9.7. And then for part 2, against Poppy's conclusion, if I put 2 there, and again, you look at the various different values, and then if you have a look at this, no skills in Welsh is 83.7. So no skills in Welsh B is greater, and then just type in 83.7 is greater than 82.6. Obviously, it's better to sort of formalize it a bit better, but that's the gist of it. And run out of room as well, and I want to make sure that I get in for the rest of the work there. So we're up to, what's that, 5 marks, and notice we've got another 5 marks to go. D. 7 4-year-old children who speak Welsh were asked to concentrate on the task. The times and minutes until they lost concentration are given below. So you got all the numbers there. And calculate the mean and standard deviation. So if I put D part 1, we need the mean first of all. So the mean is equal to sigma x over n. So that is just all the values added together, divided by how many values there are. So there are a total of 1, 2, 3, 4, 5, 6, 7. So it's over 7, and I added them up previously, so you don't have to see that. It's 53.9. 53.9 divided by 7 is going to give you 7.7. I'll put 7.70 correct to 3 sig figs. Now you do the standard deviation. So the formula for standard deviation is equal to the square root of sigma x squared over n minus x bar all squared. Original, but that's something that you're going to have to learn. If I put, so how I would do sigma x squared is I would square each of these and then add them together. So this then standard deviation is equal to square root of, now sigma x squared added together is 461.01. 461.01 divided by 7 minus 7.7 squared, which gives me, and if you just put that in the calculator, 2.56. Okay, and now it says, so there's your 3 marks, last 2 marks. For a similar group of 4-year-olds with no skills in Welsh, the mean concentration time is 6.5 minutes and the standard deviation is 3.5 minutes. Compare the concentration times for these two group of learners. Now you see the 2 marks there. So I expect a statement about the mean and I expect a statement about the standard deviation. Remembering that the standard deviation is that central spread. Okay, so it is the spread of data. So if we do for the for the mean, first of all, I can just about fit it on here. So on average, and I need to see that word on average, it's not just about, because it's asking you to compare, it's not acceptable or good enough to get the mark to just write down what the 2 values are. You can see which one's better, but you need to say on average, there you go. On average, the concentration for Welsh speakers is higher. For Welsh speakers is higher, and I want to underline average to make sure you put it in. And then the next one, the SD for Welsh speakers is less spread out for Welsh speakers. And that word about spread out for Welsh speakers. There you go, just about fits it in. Okay, and then the next question is, there you go, that's the one. A doctor knows that 34% of his patients currently take too little exercise. He believes he can reduce this proportion by putting patients through a behavior change program. To test his belief, he takes a random sample of 156 of his patients and puts each of them through the program. It is found that 40 of these patients take too little exercise following the behavior change program. The doctor initially considers using a two-tailed test. Explain why this is not appropriate. So again, there's a lot of information going on here. And again, what we've said is there are videos with the Callum Cymru website that you can look through and pause this, work through it yourself, and then see if the answers match up. So behavior change program is designed to reduce the proportion of patients who take too little exercise. And that word proportion is important. So if I write it as behavior change program, so that would be this. The behavior change program is designed to reduce the proportion of patients take too little exercise. Part B, 1. The doctor then decides to use a one-tailed test. Explain what is meant by the p-value in the context of the question, all related to the context of the question. So the p-value is the probability of 40 or fewer patients taking too little exercise. Fewer patients taking too little exercise after the program. Okay, and now let's get into the hypothesis testing. Test the doctor's belief at the 1% level of significance, stating clearly the conclusion that the doctor should reach. So we've already defined what x is. So x is the random variable binomial 156 0.34. So that's your 34% is the probability, and your 156 is the number of patients. You're then looking for H naught, which is stating that P is equal to 0.34, and then H1, which is P is less than 0.34, excuse me. So that gets you 2 marks before you do anything else. You've stated the binomial, you've stated what the null hypothesis and the alternate hypothesis, and then it's a case of using the calculator or looking up tables, px less than or equal to 40, although I don't think tables would be appropriate because it's 156. So it's going to have to be using the calculator, and that is equal to 0.0155, which I'm approximating to 1.55%. So then I would say that 1.55% is greater than 1%. Okay, so now what does that actually mean? Okay, so I've got 5 out of the 6 marks. I've got to state, what does it mean? Well, it means that there is insufficient evidence at the 1% level to reject H0. So there is insufficient evidence of E. I'm going to rub that out. The 1% significance to reject H0, which means the behavior change program has the desired effect. Behavior, I should have simplified it, change program is the desired effect. So as he said, look at how many marks the things are, look what you can do, put everything down that you can do, and then move on. Just take your strongest part, either the mechanics or the stats, whichever is your strongest, do that one first so that you can pick some up as many marks as possible and you can maximize it. Hope these videos have been helpful. Thank you very much.